Welcome everyone. My name is Saqib Ahmed. Again, I've been working in the Java card group at Oracle/Sun for a long time, for about 19 years now. I am the architect in the group now. The reason I wanted to do this presentation was basically I go out and talk to people, and the moment you mention the moment I mention anybody that this is that I work with Java card, nobody gets what Java card is. People, then you have to mention to them, all right, you got a payment card in your pocket, that's probably a Java card. You got a SIM in your phone, that's probably a Java card too, most likely a Java card. So most of us are carrying around cards in our pockets, which are Java card, never knowing exactly what that small chip contains. So that's the idea of today's meetup, to talk about what is on that small chip, which and more specifically Java card. There are a lot of chips out there which have other technologies on them. On them. They have proprietary cards. There are cards from Microsoft came up with something called a .NET card a long time back. I don't know how alive is it right now. I haven't heard much about it lately. But major standard, which is referred to in most of the standards that that are used in the mobile world or the payment world or anything like that, is Java card. So you take up the specifications for ETSI, which is the European Telecommunications Standard, which defines which is the organization that defines the European telecommunication standards, and that it's SIM toolkit, which is the programming and the program that runs on your SIM. The specs for that SIM toolkit are based on Java card. I mean, they're generic, but they refer to Java card as well. Then Visa, for example, refers to Java card for their specs for payment. Then MasterCard uses Java card. It's used in a lot of other areas as well, but these are some of the core technologies, core areas where it's been used. So we'll go over this. This is something that Oracle has put in there. It's a safe harbor statement, meaning that whatever I talk about here is a general product information. It's not a promise of any product deliverables or anything like that, or pricing, which may change at any time at Oracle's discretion. So the agenda of the presentation itself is that I'm going to give you an overview of what Java card technology is, where is it being used, and then we will go into some key concepts of the technology. It's quite different from the mainstream, I wouldn't say regular, but mainstream software technologies that are out there. I wouldn't even say Java, mainstream technologies that are out there. So you won't see anything like this when you study regular Java, this is going to be different from regular, even though it says Java card, because it's based on Java standard. It's still quite different from Java when it comes to the internals and the virtual machine specs and things like that. It's a different beast altogether. Then you won't see anything like this in in other technologies, cloud technologies, Microsoft technologies, things like that. It's quite a different technology which most people are not aware of, and it's an opportunity to learn about it. And then in the end, we had a latest release of Java card, which is here's my badge. Which is the 3.1 release. It was released in January of 2019, and the main focus of that release was towards IoT security, because IoT is taking off, and Java card is uniquely positioned to be used in the IoT technologies, so for security for IoT devices. So Java Card as a platform was designed for devices that use hardware security. So it was designed about 20 years ago in about 97, 98 timeframe, giving you a little bit of a history from that perspective that there was a company called Integrity Arts, a long time back. It was before 97. They came up with the first version of Java Card, which never actually became a standard itself. There was a competing standard. I mean, there were other companies working on it. Schlumberger, for example, was working on it also. Then Sun Microsystems bought the Integrity Arts company, and that came into, and then Sun promoted the standard and took the ownership of the technology itself. And from there, it became a standard which was used which was geared most towards smart cards for SIM cards and ID cards and things like that. There were cards being used before Java Card as well. I mean, there were smart cards have been there for a long time. But the main advantage of using Java was, it's the standard itself. The programmability of a card becomes extremely easy because, every vendor was using his own native language or native APIs or assembly or something like that to program on the card itself, and the card was very hard to program. The learning curve was very high, so when you use Java, even though there is still a bit of a learning curve, it becomes exponentially easier than programming in assembly or programming in core using the native libraries. So since it was designed, it was geared towards SIM cards and smart cards in general. The idea was that it is going to work on a very resource-constrained environment. So you have a very small processor, you have very limited amount of memory available. Memory, I mean, like we have hard disk space in smart card world. We work with flash or EEPROM or something like that. And then the I/O protocols had to be aligned also to work with that kind of an environment. So I/O protocol that is being used, you probably never heard of it, is called the APDU protocol. It is defined in the ISO standard 7816-4, and that is the protocol that is used to communicate with the smart cards even now. So it's been like more than 25 years, and it's still the main protocol which is being used to communicate with the cards. Now we are evolving the standards to be able to use different protocols because the install base is increasing. Like I said, we are working towards using the same technology in the IoT security market. Then the IoT requires that you are able to support more protocols than just APDU protocol, which is very limited again. So again, like I said, these restrictions came from the the background that it was geared towards smart cards and SIM cards, to be more specific. So the major or key value propositions were that it was interoperable. I'm sorry.
If the next slide, stop me, but I think I know, but I remember when I joined Sun, I had no clue where it's used.
Yeah, I'm going to talk about that.
Okay, because for me the wow this is nice, but the wow comes when you realize how everybody here is using Java Card without even knowing.
Yes. So I mentioned about it initially a little bit because I said when I talk to people about that I work in Java Card, people don't know, but then I say, okay, you have a payment card in your pocket that has a chip on it, and that chip runs most likely Java Card on it. Then in your mobile phones, your SIM is most likely Java Card. That's the biggest market for Java Card itself. And then the ID cards and things like that in a lot of places are also using Java Card. So I'll go over the usability of the things of where it is being used in general also. But so in reference to the previous technologies that were available before Java Card came, the technologies were very specific to a specific vendor. They were not standardized. So in this one provider, so for example, I write an application for Java Card. For a smart card, I was not able to take that application and run it on a different vendor's card because the technology was totally different. This provided you a standard, so your application was interoperable on different platforms. Then the connectivity plus security was combined into one thing. So SIM is providing the subscriber identity, and the cryptographic APIs on the card itself are providing the ability to have the keys or the identity verified in a secure manner of a mobile phone holder. And like I said, programmability was much easier because you were using Java Card and not programming in native. And then if you wanted to upgrade your Java Card or something like that, the updatability was also easier, especially for your applications. The platform is still a bit of a climb, but the applications were much easier to work with. Then the typical secure hardware with Java Card is deployed. These are the examples of it. You can have Java Card on a secure token, which could be a USB device. You could have on a SIM card, which is in your phone. Smart cards in general. Then a tag or e-passport. Most of there are standards defined for e-passport, which are again based on Java Card technology. Then you have the embedded secure element, and which is basically you take the smart card chip and you solder it onto an existing board, system on a chip. And then you have an integrated secure element where it is part of the design of the chip itself. It needs to run on its own, so it's still a separate area altogether in the chip, but it's part of the chip design itself. Now this is where it is being used. So finance, your contact and contactless payment, and your loyalty applications. So for example, on different cards, and you're able to collect points and things like that. Then telecom, you're using it for your SIM applications, network management, and things like that. There's somebody else. And then you have subscription management. So for example, the SIM is issued by a network operator, which is like, for example, here you have Verizon or AT&T or T-Mobile or something like that. They issue you a SIM, so they're controlling your subscription to their network through that SIM, and that SIM is a Java card. Then you have access control. So for example, my access to the building is controlled by Java card. If you go to the Apple campus, for example, they're using their smartphones themselves, which internally at again uses Java card technology to allow access or control access to the building and things like that. So ID is a major market. It's in the your military ID, for example, Department of Defense. The ID is being used is a Java card, and then you have like e-passports that I mentioned. Many of the countries, their national ID cards are also based on Java card. Even Pakistan, proud to say that. I was able to find out that the card was actually a Java card and was issued by a French company. Then automotive. This is a new area where Java card is being used. So for example, many of the cars these days, they allow you connectivity. So in your car, your update to your system software. So cars are running software these days, right? I mean, like for example, somebody told me Tesla does not call itself a car company; they call themselves a software company for some reason. So they can update the software whenever they want, and the connectivity is controlled, and the security of the connectivity is enabled through Java card. I'm not saying Tesla per se, but many of the other top brands such as BMW, such as Mercedes, and things like that. So Europeans mostly. These were the typical markets that were out there that were using Java Card already. Then the new markets where it's being used are the mobile payment market. So you might not know, but your iPhone contains a SIM, which is a Java card, and their Apple Pay is based on Java Card itself. It uses NFC, which is just a communication technology. Underneath, underneath it for cryptographic purposes and things like that, they're using Java Card itself. Then the Google Pay, I think, was also using Java Card. I'm not exactly sure about that, but it's being used in a lot of other areas as well. Then wearables, where the connectivity to a network is required. So for example, you have a watch which needs to be connected to a mobile network or something like that. Then your watch is going to need connectivity to the mobile network, as that's probably going to require a Java card for, again, for your protection of the data that is communicated with the network. Then payment and your health data protection and things like that. So a lot of wearables these days, they contain a lot of health data. So for example, you have health monitoring systems which people are wearing, which let the doctor know if your blood pressure is going up or down or something like that. Hacking of those things is a serious business. So I mean, those devices which need such connectivity to the network they're a big market for Java Card. I'm not saying that they're using right now, but these are the emerging markets where Java Card is being proposed to be used. Then smart meters and gateways, like for example your electrical meter, or a lot of devices in your home which do not really have direct connectivity to the network itself, but they connect to the network through a gateway. And the gateway needs to have the network connectivity or capability of a network connectivity. And that, again, wherever there's that kind of purpose, security for network connectivity is required. Java Card is a very, very robust, secure chip that you can use in these kind of scenarios. Then the IoT security. This is where I mentioned that the 3.1 release that we had in January was mainly geared towards. So we have new APIs, new support for new communication protocols. Like I mentioned earlier, the communication protocol that we use right now is called the APDU protocol, and it's archaic, but it still works for the Java card world. Whereas where the data being transferred from and to the card is very small, so that works. But if we are going to work in the IoT world, then we need different kind of application models, different kind of communication protocols, and things like that. So that's where your, the latest release was geared towards the IoT security. So a little bit of a history of the Java card itself. I mean, and it's been over 20 years when Java card came into the market. It's been a leading platform for SIM and other technologies. So this slide gives you a little bit of a history that the first one came in 1997. Then the first million cards were in 99. In 2002, we had our first release, which contains support for logical channels. So logical channels is a way of having multiple applications sitting on a card at the same time being active. So when we go about the technology in depth, we'll talk about logical channels themselves, and the restrictions on the platform itself. Then we also introduced RMI at that point, and then something called object deletion, which is again, it's Java, like I said, but it's different from Java. Whereas Java, you can write objects and forget about them. Java card is not like that. You have to, it's a very restricted environment, so you have to take care of the objects that you create, and make sure that you delete them afterwards. So object deletion is a mechanism that allows you to do that. And then, a lot of crypto has been added, and support for MyFair, contactless, things like that. Those were added in the subsequent releases. Then we had a major release which was Java Card 3, in which we created two versions of Java Card. One called the Connected and one called the Classic. The Classic was the one that I've been talking about so far. The Connected was designed to be something, an entity on the network by itself. So it had a web server of its own. You could write servlets to be downloaded on the card and things like that. But that technology, I won't go into a lot of details of it. That technology was way ahead of its time. The devices that it was targeted towards are still catching up. The hardware was not really capable of supporting it, so it's shelved for now. Maybe in the near future we'll find some use case for that. Then, I won't go into a lot of details of the other things. I've already talked about that. So just a little bit of the security of the platform itself. You have a Java Card virtual machine, which is actually controlling access to the low-level hardware. So the Java Card applications running on the top, they don't have access directly to the hardware itself. It's Java, so the standard Java access controls, standard Java flow controls, and things like that are in place. Plus some additional controls that we'll talk about later in the presentation itself. Then you have the API, which is used for encapsulation of sensitive data and things like that. It provides you state-of-the-art cryptography, biometry, key management, PIN management, things like that. So everything that are required to be in a secure token. Starting from the hardware itself, I'm not going to focus more on the hardware in this presentation. I'm going to talk about only the Java Card technology, which sits on top of the hardware, which is more or less hardware agnostic. Is that the hardware itself is a highly secure hardware where, if you look at the specs for the security in the hardware, you'll be surprised how many security aspects are designed into it, like self-destructing, things like that you see in Mission Impossible movies. So, those kind of technologies, they're really living technologies that you can see in this area, in this particular technology. Then you have the applications, which are themselves isolated from each other. So not like Java. So for example, Java, you don't have multiple applications are running in the same VM. They're able to access each other's objects. So if somebody is able to, for example, attack a VM and mess around with a pointer or something like that, with a reference, then it's something that is that cannot be caught in Java Card. In standard Java, because there is no access control between applications. Whereas in Java Card, there's something called a firewall, which sits between applications. So the objects, even though you may be able to manipulate a reference or something of an object and let the other application get access to it, but as soon as it tries to access it, the firewall mechanism jumps in and it says, sorry, you're not the owner of this object. So there's some sort of an ownership perspective to it. And then there's, this is not part of the core Java Card technology itself, but there are other standards that are built on top of Java Card, such as there's a standard called Global Platform, which is used to manage the applications on the card and manage the security policy on the card itself. So all the content, etc., is managed. Java Card does not itself specify how that is done, but it's the Global Platform specifications which run on top of Java Card, which are specified on top of Java Card, which allow you to do that. So there is another level of security policy which is enforced by another standard. So for all the secure hardware tokens or secure smart cards, there's a requirement of security certifications, which is a very painstaking process. It requires, that some of the vendors, they certify the products, their products themselves, where there are certain industry standards such as common criteria, or some such as FIPS standard or something like that. FIPS is for U.S. Common criteria is defined in Europe. They have defined criteria for certifying Java cards, and smart cards itself. And Java card makes it much easier to certify a smart card than a regular smart card itself. So Java card, as part of a deliverable, we provide something called a protection profile for the Java card itself, which specifies all the attacks that could possibly be done. So it's coming from a Java card specification perspective. So we're saying that this is how an attack could be done on a Java card, and this is how the Java card protects against that, and this is how it's specified in the specification. So if somebody is saying that I am Java card compliant, and they have a protection profile as a reference to say we are protected against all these attacks, which are already mentioned in the protection profile, which is also certified by common criteria.
So unlike Java MEOS, it's not that you have a TCK, you have these two.
We have TCK also. But
TCK is in order to be called Java card, and then that's
correct.
The layer on top of it?
No. So TCK is to say I am Java card. So TCK is, by the way, who are not aware of the TCK terminology. TCK is Technology Compatibility Kit. It's a test suite which is issued by Oracle, which the people who are developing Java cards, they run this test suite against their products, and are required to pass the tests in the product in order to call themselves their product Java card product. So this is on top of that. This is not, TCK does not give you a security certification. It's just telling you that you are Java card compliant. Whereas security certification is coming from common criteria, which is saying that is it protected against these attacks? And common criteria has different levels. So it starts, I don't know, I haven't heard of anything lower than EAL, assurance level 4 or something like that, but Java card specs are at assurance level 4, whereas the products are usually assurance level 5 plus, which means that where they're manufactured, the facilities are highly secure and things like that. So it entails much more than Java card itself. So you may have access controlled locations where the Java card is being built. There should be no connectivity, internet connectivity, so somebody can hack into the software that you're building and things like that. So there's aspects of the building security, aspects of the software security, environment security, everything like that is built into common criteria. But what we are doing here is only talking about the specs, that the specs are secure against these attacks. So if somebody implements the specs like we have mentioned, like Oracle has specified, then he should be protected against these attacks, and this is how they are protected against them. And this is what is specified in the protection profile. And then the good part is that you can certify your applications separately from the platform. So you can, in the previous or other smart cards, which are native smart cards, you have a whole bundle of the applications as well as the OS and everything all together, which has to be certified. So if you change something in your application, the whole thing has to go back to the certification authority, and the certification takes a long time. It can range anywhere from six months to 2 years or something like that. So if you are based in Java card, you could certify your applications separately from the platform itself, or with the platform itself, and there's a possibility of doing that. So as a whole, also you can do that. So this is how a solution, a Java card solution is built. I mean, Java card solution, but that I mean everything. So content, the platform, etc. So where Oracle comes in, it gives you the Java card specifications. It gives you the test suites and a reference implementation of Java card. The reference implementation is not on a chip, it's a Windows implementation. So it's basically verifying the technology compatibility kit to verify that that kit is actually correct. And then people can, there are different level of licensees. Some licensees can see the source code of the reference implementation. So if they want, they can see how certain feature is implemented and things like that. And the the test suite they're required to pass if they are going to call their product a Java card, and then the production profile, which I just talked about, which is required for certification. Then the Java card products themselves, which are the vendors like Gemalto, like Oberthur or IDEMIA these days. They take these specifications, implement these specs, and issue products, smart card products, which are after passing the test, they can call Java cards. And then there's the content, which is developed either by these companies themselves or by other vendors who are just into developing applications on top of Java cards. And the applications include, your applications for e-passport, for example. When you go to the airport and the officer takes your passport and he scans your passport, there's an application running inside the passport and the smart, the smart chip, and there is a standard for that one. So the Java card product manufacturer may not necessarily be building that application. It may be coming from a third party. There are standards for those applications. So, for example, somebody could be developing applications for MasterCard, which has its own standard of applications. Visa has its own standard where they develop their own applications for payment products and things like that. So this is where so far, any questions? We're jumping into the technology itself. I've given you a very high-level view where it's being used and the history and so
Today,
forth.
I know you talked about it and covered it in the very beginning, but today, what problem I as a startup, you decide what, it will solve better with Java card than with anything else?
Well, mainly it's been focused towards, in the past, it's been focused towards identity management. So if you have an identity management solution, so for example,
So BlackBerry today has, for enterprises, they own the market more than anybody else. Is BlackBerry in their managed devices uses Java card?
I don't know. Simple answer. I don't know. I'll have to check on that, but I'm not sure. But there is so for example, sometime back we were doing an identity management product at Oracle itself, at Sun itself, actually, which was basically you take your card, you take it to, there is a card reader with every computer that you're connected to, and your session is, it was somewhat
You're talking about the Sunspot?
Yeah, not Sunspots.
Whatever the name
Sun,
was. Never mind. Sundesk.
no. Sun
Those
was
things-
help- Yeah, I know.
I don't remember.
But anyways, so,
Okay.
and Sun was a long time ago, so I don't remember exactly.
But
Yeah.
today, for example.
Yeah, so that, I'm just giving an example of where it was being used. So your sessions were managed between different computers. Then, so identity management solutions. So for example, you have your smart card, which is controlling your access to the buildings, which is controlling access to the websites you can access inside your network or something like that, or other resources. Then, so identity management is one thing. Then, like I mentioned, the emerging use cases are the IoT security use case. There was a recent law passed in California which requires each IoT device to have its own keys for security. It needs to be individually secured, which was not the case before. Even now it's not the case. There is a deadline of 2020 or something like that, by which all IoT devices, I'm sure it'll it'll be more lenient. I mean, it'll be relaxed. But right now, there is a single key issued for a lot of IoT devices which are issued because simply the devices themselves do not have the capability of creating keys and managing keys and things like that. So that would be a case where every device itself, even though it's a small device, is able to create its own keys and able to onboard itself with the network and things like that.
Can it work, since you mentioned IoT, can it work for headless devices?
Yeah. Well, Java Core technology is headless, right? I mean,
no, but I was thinking about all the connected microwave and all of that. And
yeah.
Actually, there was. I'm sorry, I don't work for BlackBerry. A BlackBerry demo that they hacked an office because they connected to the connected kettle. It was Wi-Fi because the kettle had an application to turn it on for the people who really don't want to wait in the kitchen to see the water boiling.
Yeah.
And the video is available on the web. But had they used Java Card to hack so easily to the network through the kettle from just hacking into the Wi-Fi from the parking lot would be harder?
Harder, much harder. So, I mean, Kettle probably didn't have much security built into it. And that's the problem. I mean, you may not think, oh, I don't need security for my Kettle. Why would I need security in my Kettle?
Exactly the case that they made.
Yeah, but the problem is that your Kettle is connected to a network. And it is providing you access to the network itself. Like I said, in the medical devices, some device is controlling the amount of insulin that a patient is getting or something like that. Somebody hacks into it, messes around with it, patient dies. There is a big lawsuit waiting to happen for the company which is manufacturing that. Not to mention that person's life, which is not that important to corporations, but
very sensitive of you.
Yeah. So, but in any case, so that's, I mean, these are the main use cases that I can think of right now. So this is the overview of the complete stack. I mean, we've already looked at it a little bit in the previous slides as well, but we'll go into a little bit of more details. So Java Core platform, again, as I said, it's designed for small, low-power, secure chips. The idea is that most of the chips out there are supporting the same APIs, same features, things like that. So you can take one application from that you've written from one vendor to another vendor. So it could be run on multiple things. So it's adaptable, and it's the Java Card OS itself is hardware and OS agnostic. So you can take, can be ported to multiple embedded OS. Then, so it supports vertical market extensions. So, for example, you have Java Card, which is geared towards SIM. So there you will have extensions specified by European telecommunications standards, which is ETSI. So which are implemented on top of it. You have applications for identity, e-passport, something like that. So you have different. So it's extensible platform based on the market itself. So you have payment, you have ID, you have others. So they can define their own applications on top of that. Then, like I mentioned, the applications are, since they're isolated from each other through a firewall. You could have applications from different vendors running on the card without messing around with each other's data. So their data is secure. So the different components of the technology itself are basically, you have at the lowest level you have the Java Card virtual machine. Then you have the Java Card runtime environment, which is controlling, which defines the application model, life cycle, memory model, things like that, and the security model, which is basically your firewall mechanism. Apart from whatever Java prescribes, and on top of that, we have the firewall mechanism to isolate the data between different applications. Then you have the APIs, which provide you extensible network, extensible framework of cryptography, key management, things like that. So now, how is Java card different from standard Java? So you have these are the features which are different. So it's a language subset. It's a very small resource constrained device on which Java is supposed to run. So a lot of features which are in standard Java are not available in Java card. So starting from the language itself, you only support in Java card Boolean byte shortened int. Int is also optional. So many of the Java cards out there don't even support integer data type, just because it takes 4 bytes on the stack, and the stack is very limited. So if you want to have spare some stack space, you use 2-byte references. So one-dimensional arrays only supported. Objects are supported, but like I mentioned, object creation happens. There's a different memory model altogether. So the object creation is not supposed to happen like it happens in regular Java, because the object, once you create it, it's going to stay there. It's not going to go away until you request it to be deleted itself. Then packages, classes, interfaces, exceptions, etc. Those are all the supported features, or object-oriented features, inheritance, virtual methods, etc. Optional object deletion that I talked about earlier as well. It's garbage collection, but on request. So it doesn't happen automatically. In Java, in standard Java, it's the VM itself is taking care of seeing, okay, now I need to run garbage collection to reclaim memory and things like that. Not in Java card, you have to call this mechanism itself, and that's why it's not called garbage collection, because to differentiate it from Java, so that people don't think that there is garbage collection in Java. Then the unsupported features, large primitive data types like long, double, float, even int, I said, it's an optional thing. The characters and strings, they are not supported. Multi-dimensional arrays, dynamic class loading, security managers, finalization, threads, etc. So it's a single threaded environment. Multiple applications cannot run at the same time. This is where the logical channel things come in. I'll talk about it in more detail in the following slides, where you could have multiple applications which are active at the same point, but which are not at the same time, but which are, by active meaning that their status is active. They're not actively running at the time. So there is a process of selecting an application on the card and deselecting an application on the card based on what you want the card to perform. So for example, let me give you an simple example. So for example, you're talking on your phone, and you are texting on your phone, and you're passing through a transit turnstile. So you're making your payment on the turnstile itself. So you're doing two operations. You're actually actively talking to the network tower. So that's one. And then you are also using your payment mechanism. So there are two applications running seemingly at the same time, but not, they're selected at the same time. So for example, on one interface, you're talking to the turnstile, which sends one request in for the card to do something, and while that is happening, the network is waiting, and when that response goes back, the second request from the network comes in, and that gets processed and that sends back. That's sent back. So at one point, only one request is being processed, but multiple applications could be selected at the same time.
Will the call drop?
No. It's not during the call establishment. It's during there's a lag time available. I'm not very familiar with how the network operations work, but there is a lag time available in most of these processes. So the API is, I won't go into details of the API. I'll have pointers at the end of the presentation for you to go on the internet and find out more about the APIs and the VM itself. So we have
application framework, which includes Java-Lang I/O framework, which is controlling the lifecycle of the application, things like that. Then you have the cryptographic framework, which is it's Java card security, crypto. You have security framework, again, and then biometry, big numbers, TLV structures, time management, certificate management, pseudo-random functions, all of these. So very extensive or something in a token. So this is an overview of the VM in the card. So the technology, the virtual machine technology is very different. So you have, in the standard Java, the VM is a big software by itself. Whereas in Java card, it's a split software. So not everything can happen on the card. So the standard VM, what does it do? When it is required to load a class, it loads a class, it resolves all the references in the class, does the verification on the class before even loading it, does the verification on it, does the linking, name resolution, all of those things. And everything is in one go, and then the execution. Whereas in Java card, the technology is split into two portions. There is a portion which is running on the card itself, and there is a portion which is running off card. So the off card portion is the one which is doing the verification of the class files, and it is basically taking in the program that you've written in Java, and processes it through some tools which are called converter and the verifier, and it outputs something called a cap file at the end of this process, which is more geared towards execution on the card itself. So, for example, like I said, mentioned earlier, card does not support strings. In standard Java, your class names, your file names, your method names, everything is in strings. So everything is converted to numbers. So these are called tokens. So the converter takes care of it. So everything is numbers from now on. So all the strings are converted into numbers, they're tokens, and there's a way of mapping a token to a string afterwards, but then that is your facade, which is the export file, which is the second portion, which is built by the converter. So it takes that whole, your program that you've written, it could be multiple packages, it could be one package, and converts that into a compressed applet file, which is called the cap file, which is then downloadable on the card. So all the name resolution, all the verification has already happened, and then that cap file can be taken and loaded onto the card, where it is linked finally with the on-card components and can be run on the card itself. So the on-card VM is only doing the linking part with the components on the card. It's not doing any name resolution or anything like that. It's only going to execute the application itself. The memory model. So this on the card, the memory is divided into three areas. Somewhat four areas, but three areas to be in general. ROM contains mostly the OS code, which is your VM code, as well as the lower level OS code and things like that, which is not going to change. Then your persistent memory, which is flash or EEPROM, it is going to, every time you do a new or something like that, the object that you're going to create is not going to be created in RAM. It's going to be created in flash or EEPROM or the non-volatile memory. So that's why it doesn't go away. So the theory behind that is that you insert a card into a card reader and you pull it out before it does any operation. It has done something. Where did that something go? Every time, and between different invocations of the card, or when you insert the card or something like that, you don't want the whole startup process to start all over again. You want the objects to stay there. So for example, the VM, it creates a lot of objects when it starts up. It takes a long time to start up initially.
But once it starts up, the next time, the VM, what it needs is going to be already there in Flash. It does not need to create all those objects again. It can just reference those straight away. And all of the objects are persistent across sessions of the card. CAD is, by the way, card acceptance device. I'm sorry if there are some certain terminologies in here which you may not be very familiar. So if you, at any time you have any questions, just raise your hand. Feel free to ask. Then there's, since, like I said, I mean, the security is the main reason behind, this technology itself. So you have to have a transaction mechanism, which means that as a programmer, I can say that a certain operation must completely finish or not at all. So for example, if I'm updating a key for an application, I don't want to leave it in the middle where the application is not even able to use the key is messed up. I should be able to update the whole key in one go. So that is supposed to happen within a transaction. So if, for example, you insert a card into a reader and you are the key is partially updated and you pull the card out, and the next time you put the card in, it's going to restore the old key which was previously there before the update started. So it ensures that at some point, unless the transaction was completely finished successfully, that key is going to be, that data is retained. Then there is different kind of transient memory. So transient memory is RAM, basically. Different kind of transient memory. So you have memory called the clear on deselect memory and clear on reset memory, and of course stack, which is separate altogether. But clear on reset memory is the type of memory which is cleared of all its content when the card reset happens. So you take the card out of the reader and you insert it back in, clear on reset memory is gone, so you don't have any data, it's all zeroed out. Whereas clear on deselect memory is a memory assigned to an application where when you select that application, the memory is assigned to that, and it can create, it can keep its data in there. But as soon as that application is deselected and some other application is selected, that data will be gone. So it's to protect the data between different invocations of the application. So it's another level of data protection. So no data is remaining. If you decide to put some data into clear and deselect memory, every time your application is deselected, that data is going to be gone. It's going to be wiped out. So if you want to keep your session, so if, for example, you don't want your data to be shared between different applications or something like that, where there is a mechanism which allows you to do that. But if you don't want that, then you basically are going to use the clear and deselect memory to ensure that no data remains in the memory after your application has been deselected. The RAM memory, the RAM, I shouldn't say RAM memory. RAM is by itself, we know that it's not going to be required. I mean, the content of the RAM are not going to be required across different sessions, so the data is not transacted. So, I mean, the transactions are only happening in Flash where the data is completely updated or not. So that is only guaranteed in the transaction in the Flash. And other than the mechanism of transaction management, there is a mechanism guaranteed by the VM itself that, for example, if you're updating a field, it's up to the field level. The field itself will not be, I mean, on the high level, we see it as a field, but the field may if it's a 2-byte field or something like that, it'll have 16 bits. So every time maybe you're updating something and it didn't get fully updated and you lost power or something like that. So it's a field level updates which the VM guarantees that are going to be either fully completed or not at all. So then this is the part where I talked about, applications being allowed from different vendors, which are able to sit on the same card because the data is isolated between different applications. So there's a firewall mechanism which is over and above what Java,
provides you itself. So, so every object that you create basically has an owner stamp. So I'm an application 1. I create an object that is going to have my stamp. There is an application 2 out there from somebody else, which it creates a different object, and that has an ownership stamp of a different owner. So if by somehow some attack or something like that, like I'm able to mess around with the card signals or electronics or something like that, then I'm able to manipulate a reference, and I'm able to get a reference to somebody else's object. When I try to access that object that has a stamp from a different owner, I will get a security exception. And many of the cards will go mute at that point. You have to go back and talk to the card vendor or something like that. So there are, so all the applications and their data are isolated from each other. There's a very specific mechanism using which you can, it's called the object sharing mechanism, through which applications can share data between themselves, but it's very restricted. Then the communication, like I mentioned, APDU-based communication. APDU is specified in the ISO specification 7816-4. It is, it basically, it's a big array, like 256 bytes that you can send it at one point. It's a half duplex communication, so you send in some data, you wait for the card to respond back, and then when the data comes out, respond back to, you can send it to you. I won't go into a lot of details of it unless you're interested, we can talk about it later. Then the, like I said, the Java card VM runs forever. Once it starts up, it doesn't die until you decommission the card. It only is removed when you remove the power. It's only going to stops temporarily. It's going to sleep mode or something, but it doesn't kill itself or something like that. It recovers everything from the previous execution once the power is restored. And similarly, once an application is installed on the card, it is going to remain on the card until it's uninstalled from the system registry. So until it's not removed from the system registry, you can access it. And all its objects, unless it decides to delete a certain object, is going to remain there. So these were the key concept of the technology. I can quickly go into the next session if somebody has any questions so far. Answer those, otherwise we can go to the next part.
On the power, so you said that it like runs forever, but if it does drain power from a device successively, like how's that for performance?
No, so
Does it impact performance?
the card itself, so for example, you have a SIM card is getting power from the phone. So it only requires power when it's executed. So it's up to the system to provide it. It's reliant on the outside system to provide its power. So it's controlled by the outside system itself. So from the power perspective, it's whenever from our Java card specs perspective, we only care about the contents of the memory if the power is lost and the power is restored. So we want to make sure that the memory contents are intact, or and provide the application developer the same capability that if they're updating something, the power is lost, they don't lose what they were updating. But the power is always coming from an external source.
But I'm just wondering how much additional power this would require for.
I'm not exactly sure. It's very tiny, but I'm not exactly sure how much. I can dig up some hardware specs and talk about it. Any other questions?
So one of the specs was that it has an updatable security.
Yeah.
So I'm just wondering, how would it work in practice if you have a security vulnerability, for example, in your credit card, in a chip in the credit card? How would that vulnerability would be actually updated?
Yeah. So there are two distinct kind of. Maybe there are more, but two come to my mind right away. So there's one which is a vulnerability in the application which is running on top of the OS, which is an easier thing to do. So for example, I don't know if these days you get these SMSs or something like that that your system SIM software has been updated or something like that. It used to happen on the old phones, but these days I'm not sure if that happens anymore. But what they can do is they can, over the air, they can transfer the new application to your phone, which is able to then download the new application to the SIM.
The phone is okay, but I'm talking about
the card
your
itself.
card.
Yeah.
Like
So the
credit
phone
card
then
or
installs
whatever.
the application onto the card. The card itself does not have direct connectivity to the network.
Exactly.
It's
So how is it being
talking to
updated?
it's talking through the card, through the phone or the external device to the network.
I see.
So the communication is secured through cryptography. So for example, whatever data is going to send out to the end point, to the other side, the entity on the other side, it's going to be encrypted going out of the card. So even though the phone is going to get the data that the card wants to send out to the network, the data is going to be all encrypted. So the phone doesn't have anything to do with it and cannot do anything with it. So it can only transfer the data to the card and transfer the data from the card to the network. So any application, so for example, an application, I want an application, update a payment application or something like that on my phone. What the vendor would do is talk to the to the network provider, which could be T-Mobile or Sprint or something like that, and have them download the application into the card using their network. So the whole communication between that is encrypted itself, and the data going into the card also is going to be encrypted, where the card itself is going to decrypt the data which is coming from the application provider. So that's how it's able to update the applications, delete the old applications and update the applications on the card. There is a separate mechanism which requires a much more extensive work, and for that purpose it's not generally done in the field itself. But if you find a problem in the OS itself, what would you do in that case? Because the OS is residing in ROM. In that case, there is a mechanism called patching mechanism, where OS has hooks built inside it. You can download a patch onto the card in the flash, and then every time that particular method in the OS is going to get executed, the hook mechanism basically changes if there is a patch which has been created for this particular method or not. So if there's a patch, then it executes the method in the patch and not the vulnerable method which was already in the OS, which is still sitting inside ROM, but it's not going to be executed. So this is how they generally do it. But it goes through a very rigorous security process. So like I said, sometimes taking from 6 months to a year and a half to 2 years of testing before a card is issued. That's why they're very sure about the platform itself. The applications, of course, they can have some vulnerability in them, and they're much easier to update. Okay. So the 3.1 release that happened in January of this year contained a lot of new features. I will quickly go over these. We're running out of time here. The large application support. Previously, before this release, you could only have a single Java package for an application. Now you can have multiple packages. Java, if you're writing a Java program, you're not used to writing all your code into a single package. You usually are supposed to divide it into multiple packages. So it was not there. Now it's supported. Extensible I/O model, which is geared towards the IoT market. Crypto extensions, then optimized array management, where you're able to share data between different applications without copying content from data. I won't go into detail of a lot of these things because I think already this was a very extensive deep dive into the technology itself. If you have any specific questions, maybe we can have another session where we can deep dive into other areas. But for now, I'll just keep it very high level. And what was delivered as part of 3.1 was a development kit, which you can download from Oracle's website and play around with it. And you can develop applications. It's a full-fledged kit. You can develop applications, play around with them. Simulator, and there is actually an Eclipse plugin which you can use to develop applications for Java card itself, which is part of the development kit. and then the TCK, which we talked about earlier. This is geared towards more the platform vendors which are creating Java card. So the key goals for 3.1 were to support digitized SIM. So SIM is basically right now it is your the smart card which is running in your phone itself. But there are different technologies coming out for the SIM as well, where you don't need that particular hardware itself. SIM could be an integrated SIM itself, where you could save a lot of real estate space. You don't have to insert the SIM to the phone anymore. If you want to go from one vendor to another, it's just able to update your what do you call it? The membership, kind of your subscription to the new vendor. Attestation. This is something called device attestation, which is a device is able to attest that I have not been tampered with. So there are different, when a device is initially issued, there are different calculations done on the device itself, which are stored in the device. And every time the device starts up, the calculations are done again to ensure. So, for example, you do a hash on the complete OS. That's and you're able to come up with a number. And the next time your card starts up, you do the hash again, and you match with that number to make sure that the OS of the device has not been tampered with. So there are different mechanisms of doing that. Different vendors do it different ways, and for that you require applications to run on the device. And again, adaptable attestation means that you are able to take your attestation, the mechanism from multiple vendors, and they can all be sitting on the same device itself. With the firewall mechanism allows you to do that. Multi-cloud authentication is something similar, where you have a device which is going to be onboarded in IoT, for example. You have a device which needs to be onboarded onto different clouds, and that device needs to be. So, for example, you take the example of Amazon. Your device is able to connect to the Amazon cloud, which requires different kind of credentials, different kind of security protocols, things like that. Whereas if you're talking to Oracle Cloud, it requires different credentials and different protocols and things like that. There could be two very distinct applications which are onboarding that one device to different cloud vendors. So that same device could have the credentials for Oracle Cloud as well as Amazon Cloud as well as Google Cloud, something like that. So they're all different vendor applications are able to reside on the same device. This is the firewall mechanism which allows you to do that.
Does it also support blockchain-based credentials?
Yes, of course. So I already talked about the digitized SIM. It's based on the ETSI standard. And profile switching, you're able to switch the profile from one vendor to the other. You don't have to carry multiple SIMs or something like that. If you're traveling to Middle East or other countries, many people are carrying multiple SIMs with them, so they switch the SIMs inside the phone. You're not required to do that anymore. You're able to switch without that. And
but it's not in the best interest of the SIM manufacturers themselves.
Yes, of course. I mean, but it's giving control towards more the phone manufacturers rather than SIM.
It's surely not in the best interest of the operator.
Yes,
One.
sorry.
Yeah, of course, yes.
I meant the operators, thanks. Whoever manufactures SIM doesn't care, but the operators care.
Operators, yeah.
But the new iPhones are made one step before that with double SIM phones.
Yes.
Which used to be common only in India and
a
couple of states in Europe and Eastern Europe.
Yes, I mean, like I said, people. There was I saw phones in Pakistan which have mechanisms of having multiple SIMs
No, in India they existed for a while, but only now iPhone actually went to
No, I mean,
Internet.
I'm saying the people had come up with the hacked mechanism of having
Oh,
multiple
okay.
SIMs inside the phone. So, and then the manufacturers were. So, multi-cloud authentication, I just talked about as well, that you're able to authenticate to different clouds, onboard devices. The onboarding mechanism can, from different vendors, can sit on. This is again, the security of the devices itself, like I mentioned earlier. The device is able to secure itself using its own keys, and it's able to identify itself as an entity rather than, for example, like I mentioned, many of the devices are being, right now, IoT devices are being issued and they are considered secure, but they're using the same key. All of them are using the same key. So if one is hacked, particularly most of them are hacked. So if every device is going to have its own key management, etc., is required, then this is where another use case. Adaptable attestation. Again, I mentioned different vendors may use different attestation schemes, where some may require that you do a calculation of the hash or the number that you determine, that you calculate to determine the validity of the platform itself in a different way from a different vendor, which does it in a different way. So different attestation schemes can sit on the device at the same time. So now I'm going to go through, I think we've already mentioned it.
How was the 3.1, or how welcome is it?
It's very well, actually. The protection profile, like I mentioned, protection profile is generally required to certify your products, and the protection profile used to take a year and a half after the release of the product. So the specs itself to come up with, and the vendors usually don't ask you for it very fast, but we're already getting requests that we need to get it fast because we need to certify our products.
And I'm sorry that I ask less about the technical, but more about the
Business.
the business, because
Yes.
I care for the product.
So there's a lot of interest.
But if the major, I am assuming, the major customers, profile of the licensees of Java Card, are they the manufacturers of cards or companies that develop solutions? Goes back to the carrier, because if I'm the carrier and I'm aware that the card can do it, I can have the feature but actually not activate it because it may
I can't talk about numbers, but the major companies are Gemalto in smart cards.
So
which are
Gemalto
manufacturers.
they're manufacturers, but they also have now a security offering that they
which
can
are-
leverage
which
this
can leverage
with
this.
a reduced cost, but without ever telling their
Yeah.
customers.
Yeah.
But it's as of now, from what you know, it's those who actually manufacture the cards.
Yeah.
So that didn't change. Thanks.
All right. So this is where I spoke that the device itself can basically authenticate itself. It contains its own keys, and it's able to authenticate using the as a distinct device. It has a secure storage of credentials, etc. So a different cloud vendor wants to use the same device. What they can use is just download their application, which is used for authentication of the device. Like I mentioned, you have a device which is able to talk to Amazon as well as Oracle as well as Microsoft. So it's what Microsoft just needs to do, or Oracle just needs to do, is download their own application onto the card, or onto the device, which is able to authenticate the device to their cloud. And this is a typical device stack with Java SE. So you have the IoT applications, etc. Then you have the part that would be interesting is the PKCS11, the crypto extensions provider. So, and that library can talk to the applications onto the PKCS application on the card, which is actually providing the cryptography functionality. TLS, if you want more details on TLS, you should look at the previous, the video of the previous presentation, which is up on YouTube now. Ilan from our group did an excellent presentation on SSL, TLS, and internals. This one is talking in general about what are the different aspects where Java card it can be used. So, for example, authenticating the server, so verifying the server certificate, generating the pre-master, encrypting the pre-master key. So those are all the ovals that you see here are confidential crypto operations which can happen in the card itself, and the card is well suited for this thing. Like I mentioned, the I/O model, the new I/O model 3.1 is extensive. Other than just the ISO-based communication, you have communication using different other protocols, single wire protocol, SPI, I2C, things like that. This is just an example of how you would use a different device application model. So instead of, this goes into more detail. I won't go into details of it. If you want, the slides are going to be available. You can look at this afterwards. But in order to understand this, I think you first need to understand the application model itself. So I'll just skip that. Again, this is the device attestation part that I was talking about earlier. You have software measurements which are done on different components. So you have the bootloader, calculations done on the bootloader, the operating system, and the applications. And your application is sitting on the card, which on the device. Sorry, I keep saying card. On the device, which is able to do these calculations for you according to your own scheme, which is specified by the vendor itself. So there can be different attestation schemes which can be sitting on the same card. This is just an example of how using the APIs, the new APIs which are available in the card, monotonic cover, and the signature API that is available, you are able to attest the application, the device. For more information, you can go to this URL, or you can just search Java card.
Or just ask you.
Yeah, and it'll take you to all these resources. So the specifications are available. Development kit, if you're interested at all, download it, play around with it. Have any questions, come back to me and I'll try to answer those. It was interesting to find out that even on Stack Overflow, there were a lot of questions asked and answered on Java card, which was surprising to me that people are actually asking questions on Stack Overflow. Then there is 2 webcasts, which also available on Java card, more geared towards the 3.1 technology, which are also available.